Bismillahirrahmanirrahim. Today's topic is related to substitution method. Here I'm going to cover exercise 5.4. As we know that an algebraic expression can also be expressed in the form of its factors. As here in this example, we are given with an algebraic expression. See, we are factorizing it. Here are the two factors and this is the product of it. So we have already studied that an algebraic expression can be factorized by using many methods, many techniques. The most common techniques which we have already studied are factorization using common factor, factorization by regrouping terms, factorization by using identities. One was the midterm breaking technique, and then factorization by substitution method. Here we are going to cover the technique which is substitution method. See, now our today's topic is to factorize the polynomial using substitution method. This is a quick technique to use when faced with complicated polynomials. Let us discuss it in detail by using this example. I have taken question number 1 of your exercise 5.4. This is the question. Here, this is the question and we are going to factorize it. So, as we know that factoring polynomial means separating a polynomial into its components, into its component polynomials. Sometimes when a polynomials are partially, or we can say particularly complicated, it is easiest to substitute. So we have taken a substitution. See, the first two terms of these two polynomials are same. So we are going to take the substitution for it. So we have considered y equals to 4x square minus 16x. So your first step will be to take your question and give it a name as equation number 1, so that after that you can relate it. So by putting the value of y in this equation 1, your equation will become like this: y plus 7 into y plus 15 plus 16 as it is. What we have done? We have taken the substitution. We have taken the value of y as 4x square minus 16x and we have substituted this value in our equation number 1. So the equation will become, instead of 4x square minus 16x, see, we have placed it with y. Y plus 7 into y plus 15 plus 16 as it is. Now we are going to multiply the terms. Here the two factors are there. We are going to multiply y with y. As a result, y square will be there. Y into 15, 15y. 7 into y, 7y. 7 into 15 is 105 plus constant as it is. Then in the next step, you are going to add or subtract the like terms. Here see, the like terms are the terms including y. The two are the like terms. And here we are going to add the constants. So as a result, when we are adding constants, the result is 121. And when you are adding the terms involving y, your answer will be 22y. Then again give this equation a name so that afterwards you can relate it. As we know that the identity, which is very much familiar to you, a plus b whole square equals to a square plus 2ab plus b square. Therefore, from equation number 1, we can write it as y square plus 2y into 11 plus 11 square. This was the closed form. We have written this equation in the form of a complete square form. We have chosen this first term as a, this term as b, a square plus b square plus 2 into b into a. See, here we have written that equation number 3 in this form. So when this is the expanded form, when you are closing it, or you are writing it in the complete square form, it can be written as y, which was our first term, a plus b whole square. This is a plus b whole square. Since we are factorizing them, so we can write it twice. Y plus 11 into y plus 11. So the last and the final step for this, it will be, you have to back substitute the value of y. See, we have taken the value for y. In the first step was 4x square minus 16x. In the last step, you are going to back substitute this value of y in this equation number 4. So this is your required answer. After substitution, this will be your required answer. So you can use the same technique for solving question number 1. As I have already solved it for you, you can apply the same technique and solve question number 2, and example number 14 and 15 can also be solved by using the same technique. Thank you.